It's just a bit of a commentary video on the relative merits of 12 volts versus 24 volts versus 48 volts for off-grid emergency power systems, because there's a lot of stuff that you see nowadays where it's either all of one or all of the other, usually more trending towards 48 volts, and other systems are not to be considered, when it really depends on what the intended use of the system is. For example, a small cabin system where you've got up to a few hundred watts of modules, a reasonable sized battery bank, up to a few kilowatt hours of effective energy storage capacity, need for relatively small inverters below 1,000 watts or so, and only for occasional use, or not constituting a large portion of the loads, or while it is a large portion of the loads, the overall amount of load is never more than a few hundred watts at any given time. 12 volts has a great deal of advantages because 12 volt lights are very common. Also, for emergency power type equipment, 12 volt stuff is common. You know, car radios, car televisions, all kinds of 12 volt truck accessories that are available from truck stops, truck stores, online retailers, etc. Switches that can safely handle 12 volts direct current, very common again. So again, they're good for systems where you got relatively small loads and you got a considerable number of them, even for some logic stuff like many or at least most, to my knowledge, CD4000 CMOS logic chips can handle 12 volts. Some 74 series that are in the 74 series logic part number, group, but they're actually a CMOS internal die architecture, they can handle 12 volts. But again, you have to check the data sheets because most can't. As well as, common analog stuff, 12 volt operational amplifiers are common. The venerable 555, that'll work on 12 volts just fine. When you get into things like 24 volts and 48 volts, that's more for big systems where you have big loads. Now, 24 volts, a lot of military stuff is 24 volts, industrial control stuff, 24 volts is both DC and AC, although only DC is relevant for in the scope of this video. 24 volts DC stuff is very common for industrial control. A lot of PLCs will run on it, or at least PLC power supplies are available that'll run on 24 volts, contactors, etc. 12 volt lights are also relatively common. Generally not as common as 24 or as common as 12 volts in the case of things like general lighting service incandescent lamps or compact fluorescent lamps, but when it comes to small, few watts and under miniature indicator lamps, they're all over the place. Or there's a rather considerable number of them in miniature bayonet, miniature screw, wire end. There's a fair number available on the market. 24 volt inverter is also not quite as common as 12 volts, but they are readily available and actually can be somewhat cheaper on the surplus market if you know what to look for, especially for things like rotary converters for military applications that are nominally 26 volts to 28 volts, which is in the range of operating potential of a 24 volt system. And of course, the advantage of those, no electronics, they're less likely to get killed by things like electromagnetic pulse. And again, switches that can handle 24 volts DC are fairly common, although you have to generally check with electronics retailers. And so that's where, small loads come in handy, because for stepping it down to things like 12 volts or 5 volts, whatever, running electronic loads, common switching chips like the MC34063 and various related chips will work on 24 volts no problem. Actually, that same thing for something like a 5 volt power supply. You can have one design that'll work on 12 volts or 24 volts. 48 volts is more for where the inverter is your primary load, because 48 volt GLS lamps, and in that range 47 volts, although those are only 50 watts, 48 volts and 50 volts are available. They're just not screamingly common. I only know of a handful of retailers that sell them. Atlanta Light Bulbs has some, elightbulbs.com also has some, although to be fair, I've never received an order for them, so I don't know how they are as far as a service or as far as a retailer, but I know I have an order pending, so that will be updated. Are they a good source or never use them? I don't know yet, but I've heard good things. But anyways, getting back to the subject of the video. So 48 volt loads other than big inverters are available, just especially for things like refrigerators, because you can get 12 volt refrigerators, 24 volt refrigerators, dual potential refrigerators. 48 volts, not so much, although I have seen at least one company that makes 48 volt air conditioners that'll run directly on 48 volts. Those are a little kind of a mini split type arrangement. And they might be available as a custom thing, but again, supply would be a bit of an issue. And of course, no, 48 volts. Just hit more mousetraps. 48 volts is quite common for telecommunication stuff, but in the context of telecommunication stuff, that's typically designed for negative 48 volt systems, which are positive grounded. The relative positive supply node is at ground potential. And that is done for reasons to prevent galvanic corrosion of outside plant wiring. Whereas most, at least the vast majority of off-grid systems, are just about always it's positive 48 volts with respect to ground, and they're a negative ground system. And of course, stuff is very rare unless you custom make it for things like a heater. Pretty much it's going to be things like heating elements, which would largely be used for dump loads, for things like 90 volt permanent magnet motors, where you just grossly oversize the motor so that it won't be bogged down by the load you place on it. That is an option, but again, those are becoming less common, although you do see a lot of 180 volt motors, but not so much the 90 volts, but again, they're available. And so a 48 volt system is where you've only got a few big loads, principally an inverter, and a lot of your loads will be 120 volts AC, 240 volts AC, whatever, and just a handful of other things for things like emergency lighting.